Good morning. Nice Sunday morning. We're back here for JEHC volume number 6 on independent front suspension design tidbits. Still working our way through the same outline, etc. For those of you who may not have watched the previous videos, etc., my name is Jason Elvis Hurd. I am founder of Tech Consulting and DIY Off-Road.com, a digital asset marketplace for the off-road industry. So individuals like myself can sell designs. For example, like here are designs from Baker Fab, I-beam stuff. So these are cut files that you can purchase and make your own universal Ranger, beam mounts, universal Ecolink, steering swingers, etc., etc. But the point being is DIY Off-Road is a digital asset marketplace for individuals like myself who design a bunch of stuff and want to sell it in a non-proprietary fashion, i.e., when we sell stuff on DIYoffroad.com, you have the right to cut the part once, 5 times, 10 times, etc., but you also don't own the rights to said parts. In other words, another individual in another state, city, town, hell, across the street, or your neighbor can buy the same exact cut files and start making those too. So you're not purchasing the ability to basically own that file indefinitely. You're just purchasing the ability to cut that file as much as you want. That's how DIYoffroad.com works. I've got a few thousand files up there and constantly adding stuff every week. So if that is something you're interested in, give it a follow. Coincidentally, so this is the last of my coilover coffee. No, we're not sponsored. But I can show you one thing that's interesting about that. Real quick, before we start this rodeo, I got two mouse on my desk, and it gets confusing. I keep grabbing the wrong one. I got to fix that. So the individual, there we go. Tyler Fever. So he started Coilover Coffee, and he was actually one of like the first dudes buying shit off of the website. Like this truck that he did, these are DIY links and some other bits. And so I kind of did, connect the dots, so to speak. So that's kind of cool. He sent us a packet of his coffee, and my wife does like it. And so, although not a sponsorship, so to speak, being that we are somewhat coffee snobs, stuff's pretty good, and that is the last of it for our current time period. But yeah, that is kind of cool to see. Holy fuck, he has way more engagement than this video. Fascinating. But look at this. Jesus. This kid's got quite the fucking following. So yeah, so he uses a bunch of, holy fuck, this is impressive. Maybe I should be taking notes from this fucking kid. DIY parts, like the links and things like that. I didn't watch it fully, but Jesus. This dude's got something going on with that. Let's see what his views and stuff are. Let's see, July 1921. Holy fuck. Nearly 1 million views on this video. Oh, that is so gnarly. That is so gnarly. Maybe someday I can be there. We all have dreams. Let's see if we can find some DIY product in this mix. It's somewhere in here. I don't remember what front end he got. I think it might have been like LSK or something. But nah, I don't think it. I don't know. There we go. There's DIY links. See? Fucking YouTube famous, bro. YouTube DIY links. YouTube famous. But yeah, so again, something cool, and thank you, Tyler. Definitely give them a shout out. Let's see if I can pull up. Let's see. I wonder if he has a website. Bet you he does. Coilover Coffee Company. It seemed to pop right up. This does look Fever Supply. That's right. His last name is Fever. So there you go. This is exactly what I have right here in the mug of hate. Not bad. Not bad, kid. Yeah, so interesting. So non-sponsorship shout out for today. I will be expecting royalty checks shortly here on that. But All good. So let's dive back in. So we're gonna be picking up on some bits for lower arms stuff. We're gonna move on to upper arms, move into some uprights, and we're just gonna keep working through this. Got a lot of cool shit to cover, and just like in the same format, I'm trying to progressively get a little bit more complex with each specific direction. Although there's just an insane amount of information to cover, so it's going to take some time. I mean, I could almost do these videos indefinitely and still never cover all the cool shit that is, in my space-like head, so to speak. But let's get going. First and foremost, let's talk back to revert back to some shock stuff. So when it comes to trucks in general right now for this side of the industry and the big truck stuff, shocks are more or less just fucked. Like, lead times are horrible. Like I was saying last video, even I, with bro deals and knowing plenty of people on both sides of the table, whether it's Fox, King, etc., like, lead times are still lead times. You still gotta wait. You can sometimes find a situation where a customer failed out on an order, and if you're in the right place at the right time and pay right there, boom, you can get that order. Like I did with a set of shocks where I pay basically retail, right place, right time, because if someone else failed out, etc., etc. So, the bro deal set of shocks deal and the getting the shocks right away, again, it's just not really how it is. Normally you're waiting 4, 5, 6, 7, 8, 9, 10 months, up to a year for some of this stuff. We have current trophy truck progress builds, luxury Purina builds. They're at 6 months, 8 months, and there's nothing in sight. So, they're going to be 10, 12-month lead times. So with that said, this is something I have been preaching to a lot of guys for the last few seasons, is there's this massive revenue stream just sitting on the fucking table. And these shock tuners, shock builders, whatever you want to call it, not the manufacturers or what would be considered like the shock OEMs. There's this huge revenue stream sitting there where they could be building shocks to be doing sort of this stuff. Let me just pull something up. Basically, sorry, just had to get that set real quick. What I'm getting at here is the ability to build shocks and this revenue stream of shocks and parts that are on the shelf, completing the custom orders, and then getting them out to the build and the client. Now, with coilovers and things like that, it's relatively straightforward because you're not, from a design aspect, I can't differentiate too much on a coilover as far as like what they're changing, other than we changed the style of the spring mounting with sort of the caps and things like that. We also changed the ends of the coilovers, so the length and things like that. But again, those are off-the-shelf parts, relatively speaking, for these manufacturers. Now, when it gets into more complexity, the bypasses, and this can get fucking very confusing and very frustrating. And I covered some of the bypass tube layout and how I kind of explain that or note that for said shock builders. And so obviously you have your can, you then have to drill appropriately the bypass tube locations, weld the bypass tubes on, hone final machine, and then back to coating and assembly. And so that process on the bypass side of things for the big shock stuff, or for any shock stuff in general, is where these lead times really drag out. And the reality is, like, you can't really get around that in these applications because these trucks are all running big bypasses. Now, I do fucking know that there are guys not doing that, like a Gordon type of truck, or maybe some more mellow-esque pre-runners that are running like just 3.0 IBPs, or the UTV guys running 3.0 IBPs. Like, I get that this point specifically is not for you fucking guys, okay? This is for the guys that are, traditionally speaking, doing bypass layouts in a fashion that is more of the traditional route, so to speak. When we design a brand new truck, etc., from the design standpoint, I fundamentally believe you should ignore bypass tube layout to some degree, i.e., let's focus on making the truck work and the other factors in place, and then we locate the bypass tubes and the layout appropriately inside of that application. And so what I mean is, sometimes you're dealing with a lot of things, especially on the luxury pre-runner side of the table, that interfere with bypass tube layout and interfere with sort of space constraints, where if I had the ability to just make custom tube layouts, all of that goes to the wayside. Where I'm going with that is, I like to fundamentally look at it And this doesn't necessarily always meet the case these days because of other situations, but I like to fundamentally look at it. I design the truck with the specifications per where we're going. Bypass tubes are a secondary factor, although you always have to have room for it to some degree. And when I say secondary factor, I'm referring to I note to the shock builder where I want the bypass tubes relative to the chassis design, not the inverse. So traditionally speaking, we would then get cans that were mock-up cans where we would then take these bad boys. These are, basically they're bypass tubes from a King 4.5, and we would then place them where we want on the assembly. We tack them in place and then send that shock back to King, and then they would appropriately build the race shocks to the mock-up set of shocks. So the process, traditionally speaking, was I have cylinders that are empty. I get them up in the truck at compression, at extension, cycling in real life, not the computer. Then we go ahead and place our tubes. We tack these guys in place on one side. So say like the driver's side. Get everything cycled. It's all kosher. Then we take those shocks off. We take the mock-up cans with the tubes, the bypass tubes tacked in place down to King. They then take that, reverse R&D, that layout, then build the custom shock. So obviously this process is time consuming. And with the lead times now, you're pushing yourself well above a year realistically for these big boy shocks. Now that is the proper way to do this because it's done in a fashion of you're not, sacrificing other aspects of the chassis design and development, especially in the luxury pre-runner stuff where it gets really tight, especially in the back of like crew cab or extended cab trucks with these different bodies. So you have all the characteristics you want, no sacrifices on that end. You place these guys exactly where you want to complement the chassis, complement the shock tuner. Hopefully, some of them are fucking annoying when it comes to like demanding bypass tube layout, but we do the best we can because you have to remember I'm on the mechanical side of the table. I'm on the shock geometry design side of the table. I'm not on the shock tuning side of the table. That is more of an art form like I was saying last time. So now we take that, we get that, shocks done. Again, massive lead time. So where I'm getting at is there is a huge revenue stream sitting on the fucking table for these guys to capitalize on like right fucking now. And what that is transitioning these shock tuner builders into a series of build it yourself kits, i.e. like these sort of mini franchises where these guys can build shocks for their customers to the specs without having to rely on the OEMs, i.e. King or Fox, to have these very extended lead times. And where I'm going with that is like exactly what I just saw KDM do the other day with this right here. So he took, and this is the exact same situation I'm referring to, where it becomes a fucking nightmare between design of truck, get shocks in, placement of shocks, put our tubes in place to get everything dialed in, shocks back. I mean, you're talking 18 fucking months, maybe more, depending on the situation. So what he's done here is he's splitting that gap. So he's not Fox or he's not King, but he can buy these tubes from them. He can buy the cylinders from them. He can drill them. He can weld these bad boys on in the location that he wants relative to the chassis designer, i.e. like I would be communicating with him relative to what we want. Then he could then cut down that lead time. I mean, we're talking a huge fucking chunk of lead time out of the equation. As a shock tuner, he is bringing revenue onto his side of the table, margin on his side of the table. And I know where some of you might be thinking of this. Well, wait a second. I'm not going to be able to do it as cheap as Fox or King. It doesn't fucking matter. It doesn't. The type of clients that are buying this type of stuff, they will pay you the appropriate amount you need hourly to get this done, because the inverse side of the table, like I'm saying, is a fucking year, 18 months out. So as a shock tuner, what I would be thinking right now is a business revenue stream model, and to increase my productivity and to also complement my own shock tuning style relative to the chassis builder I'm working with, relative to the racer I'm working with, and to basically deteriorate these lead time issues. I want to bring that on my side of the table. I want to be buying the cans from Fox, blank. I'm going to be buying a bunch of these fuckers from, either Fox or King, and I'm going to be welding them up just like this per each customer. Again, bringing revenue on my side of the table, and it doesn't hurt these OEMs. Let's be crystal fucking clear. It's not like I'm, advocating for stealing revenue from the OEMs. Trust me, they're fucking overloaded. They are struggling to keep up with this stuff, and they don't like to be in the situation they're in. It makes things not good on the side of the table of it pisses people off in the long game. While in the short game, I don't see it being a problem. In competent shock tuners, if they're doing this properly, in other words, you have to be able to appropriately place these. Like, in other words, Keith is going to do this properly. He's going to have the proper placement. He's going to have the proper drilling so he doesn't fuck up the wear bands. Again, there's a hint right there to some other shock manufacturers. And what he's also going to do is post-hone machine this appropriately, then get it coated properly. He's one of several shock builders that could easily do this. So again, there's this huge fucking revenue stream sitting on the table as a cash grab, just ready for someone to rip it right the fuck out of air. It'll also complement these larger OEMs in that we're going to deteriorate those lead times, thus getting our end clients much, much happier. So there's just a little tidbit right there, a little rant on some of the shock stuff. So if I was a shock guys, I'd be focused on stocking up on these in cans and doing what Keith is doing right now and cut those lead times down and get everyone in a better side of the table for multiple aspects. The engineering side is going to be a little bit more fluid because the communication between the shock tuner relative to what he likes, relative to the chassis, is going to be a lot more seamless. It is. That's the unfortunate reality of dealing with some of the OEMs. There's some stuff lost in translation on top of the long lead times. The end consumer, the driver, etc., race team owner or builder for that. The other side of the table is the builders. You have to remember, if I don't build anymore, I'm not on that side of the table, but the builders themselves, these guys aren't making millions of dollars doing this. So when a vehicle or a truck is delayed because of a shock package, I mean, it can fucking hurt. The builder could be sitting there and really hurting because if that build gets put on hold or stalled, that is a chunk in the shop of overhead that is literally going to start being fucking eaten up. And it's going to deteriorate their own margin and revenue stream fucking rapidly. So if I was a builder, again, I would be looking at possibly bringing this in-house. A lot of these builders have some amazing fucking TIG welders, and they're competent enough to figure out this post-home, post-machine stuff too. So again, massive fucking revenue stream, massive fucking opening in the market right now for the shock tuners, the shock builders. I mean, if I was on any part of the side of the table of that, I'd be investing rapidly in this. Get some kid in there. I say kid, but a 20-year-old kid, so to speak, that can fucking turn and burn on the TIG machine and get after it and start building these shocks yourself with all of the components. So buy all the top caps, everything from, basically you're buying the whole fucking kit from Fox, putting that shit on the shelf, ready to shred. As soon as you have your layout dialed, you're fucking turning and burning, weld and go. I mean, sure, it's going to take you some time and it's going to take you some figuring out, and then you charge appropriately. You bill out the hourly it is to do this on top of the parts, and okay, maybe the retail price of the shocks is going to cost more, but fuck, having something in a few months is in a custom tube layout relative to waiting 12 months, 18 months, yeah, huge fucking difference. So maybe you spend $800 more per bypass shock. You start extrapolating that math out, especially on the builder side of the table with that overhead loss. Yeah, it's going to fuck you way more than $800. So again, like I'm saying, heavily push anyone in the shock side of the table to be looking at this direction as a new way of doing things in our industry. I think this is far superior than the traditional method that I was referring to. I think this is going to be phenomenal for the revenue stream of these shock builders and keeping them in the black, so to speak, to be able to pay bills and things like that appropriately. So just a little tangent on that. So let's go into some lower again, if anyone has questions on some of that, just send me an email. I can explain my thoughts better. I've told this to quite a few people, and Keith, I think, is doing a good job. KDM, Keith Marigold, is KDM Shock Technologies on Instagram, like I was just showing you. And, hit him up. We just had a brand new 6100 client get some stuff from him. So, again, that was King, but this is a Fox that he has pictured here. So either side of that table can be done the same. All good. All good. So now let's dive into lower arm shock mount details. Didn't really get to that last time. And so we're going to try something new today. Fucking E-drawings, bro. See this podcast shit? Now, the mouse I have is not ideal for this, so you're going to have to bear with me a little bit on finagling this. But, yeah, real quick on that. So I have more of a traditional mouse for the computer I have that's set up to the podcast stuff. And from all my CAD work, I run a ball mouse. So it's a thumb ball mouse for that stuff. So, just a little inside baseball on that. So this might be a little bit more rough, so to speak. But let's review what I want to talk about here. We're going to go into some details on shock mounts. So common spread bolt sizes. Okay, so this is a stage 1 lower arm. Kind of a relatively simple shock mount deal. This is one of our T4 arms. Again, this is more of a pocketed shock mount deal, which I kind of reviewed that last one. And this is one of our stage 2 setups as far as the shock mounts go. Stage 2 lower arm. So the point here is let's start with common spread and bolt sizes. So the vast majority of the shocks in this application, etc., are going to be 1.5 inches width for the spacer pack. Now, you don't want to design your tabs to be that 1.5 inches of width. You got to have some give in there for welding. Depending on the arm, depending on the style, etc., we typically add 20 thousandths to 40 thousandths. So it'll be 1.52, 1.54. A good generalized ballpark is 1.53. I'd say the vast majority of stuff I do, like a lot of stuff you see on DIY, etc., is 1.53. And so with that said, you're putting that 30 thousandths of extra width in the shock mount itself, in the computer, mind you, to kind of account for the welding wanting to suck that fucker in and be a dick. So if you were to design it at exactly 1.5 and weld it at 1.5, even if you have a weld spacer in there, etc., and you pull that thing out, it's gonna want to suck in some. No matter how badass you think you are in all the other facets, they always tend to be dicks. And so, like I'm saying, anywhere from 20 to 40 thousandths is a good range. Some could go as low as 10 thousandths depending on how calibrated stuff is. But the point being is you're going to machine a spacer that goes in there for when you're welding that's going to match what you're doing. So if I'm setting this one up as 1.53, we're going to machine shock spacers that are 1.53 in inches, and they get bolted in place during the welding process. And what that'll do is help account for some of that fuckery. And it will move quite a bit, and you'd be surprised. So again, there's another little tidbit. Let's talk about downsizing remove bolt holes. So another common trick too. So if you're not doing the machined shock inserts, so to speak, or weld washers, and you're stacking laser cut plate, there's kind of two ways to look at this. Like these are stacked laser cut plate. If you do a good job of using like a shanked bolt, and I'll get to shanked bolts here in a minute, when you're setting this up, typically the bolt holes will be pretty good alignment. And so we'll cut that just to the exact bolt hole for the most part. It's kind of like the laziest way to do it, but it's the most simple way to do it. So just be 5/8, which is the standard. For big truck stuff, it's going to be standard to run 5/8 bolts for both coilover and the bypass. Some trucks are still running 1/2-inch bolts for the coilovers, for like a 3-inch coilover. And then obviously as you step down in bypasses, like if you have a 2.5-inch coilover, you run a 1/2-inch bolt. If you're running like a 3-inch bypass, you might run a 1/2-inch bolt. But typically speaking, any of the bigger truck stuff, etc., is going to be running a 5/8 bolt for the bypass and 5/8 bolt for the coilover. For these like 3.0 coilover, 4.0, 4.4, 4.5 stuff. And so with that said, one of the tricks you can deploy in this is like post reaming. And now that can be done post heat treating, which I'll get to heat treating once I go through all this stuff and my thoughts and kind of some of the style that I like to do heat treating and some of the processes with tooling. But for sake of argument here, we're going to refer to just post reaming as in cleaning this up post welding. And then we'll get into the post reaming heat treat stuff later. But in some situations, the laser cut plates, they're not perfect when they align. And so we might step that down and make that like a 14 millimeter or like a 9/16 and then ream it to 5/8. And that works really well because that'll help remove some of those slight misalignments, whether it's 5/8 thou, et cetera, between the laser cut plates. So that's a trick you could totally deploy as well. You can also deploy that trick too with heat treating, and like I said, I'll get to that as well. And I do know some guys that do that as well. And again, that's a whole nother conversation, and we'll get to that. But my point being here is, if you're struggling or you find that when you're doing the 5/8 directly from laser cut, so to speak, or you're having a headache with that, don't be afraid to step that bolt hole down to like a 14 millimeter or a 9/16 and then post ream it. So like for a 1/2 inch bolt, I might go to like a 12 millimeter and then do a post ream to a 1/2 inch. So that means I'll make my shock spacer a 12 millimeter and I'll use a 12 millimeter bolt in the tooling side of it when I'm welding this up. And then once it's all cool and shit, unbolt that, take that 1/2 inch reamer and punch that guy out to 1/2 inch and vice versa. So again, just another way of doing it. It's an added step. Mind you, the vast majority of guys do not take that added step. So different strokes for different folks. But if you're going to cut it to an exact, i.e., which the vast majority of guys do because they don't want to do the extra step or buy an expensive reamer. I mean, the reamers do cost money. So again, you have to keep that in mind up front that all these other little steps and variations and bits that I'm suggesting or explaining all add cost. And everyone has their own opinion, everyone has their own methodologies, and everyone has their own budgetary constraints to one degree or another that can make that either something that is viable or something that's just not viable. So just because you're not doing it, don't assume you're doing it wrong. Let's just look at it as there's different strokes for different folks and varying levels of badassery. And once you get into the treating stuff, you'll get way fucking gnarlier levels of badassery. But the point being with this is you can let it cool, post ream it, and party. Now, if you're just going to run that 5/8 to 5/8 bolt hole, again, you need to have a proper shank bolt in the tooling, mind you. So a lot of guys will get lazy and they won't use a properly shanked bolt when they're doing the tooling, so that one side the laser cut lines up bitchin', but on the thread side, it's going to be like 10 thou off. And again, it's just lazy. So even when you're doing the tooling and stuff, an additional step is make sure that you are using a properly shanked bolt, even in your fixturing, to not fuck this up. You know what I mean? That is a huge plus. So there's one aspect to it. And I'll get to that. Let's see. I have that in my notes to cover. Let's see. Shock on the top arm and across the turbo. Fuck it. We're going to skip ahead real quick. Let me make an adjustment. And we're going to put in shank bolts. So I'll refer that, just to make sure everyone is on the same page. So when it comes to the hardware and bolts, the vast majority of guys are going to run standard issue shit off McMaster. Great style stuff. Again, most likely fine for the mass majority of guys. It is significantly less expensive than what would be my preference, which would be like an RPI bolt. Now, when you're shanking stuff, let's bring up what shanking is real quick. And credit where credit is due. One of the guys who does sell RPI bolts, and we do send a lot of people his way for this specifically, is Craig. He's like a master dealer or some shit. I don't know what specifically per se, but the point is you can order RPI bolts from him. They're very expensive, and it's not like you can just go order RPI bolts straight from RPI. You have to do a big purchase order to get into any sort of real level. So it's just a lot easier to order stuff from Craig. But sticker shock beware, you're getting into the realm of not fucking around. So you're going to pay for the bolt, but there's a specific reason for that, and we'll dive into that. But the point here is the shank of the bolt, and I'll get into this a little bit more specifics in a second. You want the shank to go through the whole mount. You do not want to have threads in your shock pocket at all. So what you want is the shank of the bolt to engage here, and the shank of the bolt to engage here, and the threads be on the exterior of that, so that at no point in time are you riding on threads in either of these bolt holes. Now, like I said, you can do that the redneck way, redneck way with McMaster bolts real quick by simply ordering them, getting the long fucking shanks, stacking up some washers, and making sure that the thread doesn't engage on either of those. So you might end up with a few washers on the nut side, so to speak. That's totally fine. I'll get into more specifics in that. Now, that's like if you're using grade 8 bolts from McMaster. And again, a lot of guys do that and they're totally fine with it. It's significantly better than just letting it fucking ride by having threads eat up the fucking shock pocket holes. And they will. They will do that really quickly. So with that said, you're going to take your McMaster bolt. You're going to then basically figure out how it fits in there. And usually there's some finagling because McMaster bolts, the standard grade 8 stuff doesn't have as nice of a fitment as like an RPI as far as the length of the shanking. And then you're going to trim it down. So when you trim down the threads on like a McMaster bolt or the redneck way, so to speak, you always want to thread a nut on past where you're going to cut it. Ideally, cut it with a bandsaw. You could cut it with like a cutoff wheel, or you could do it in a mill. But you want to then chamfer that edge and then run that nut back over, or run something over to clean up those threads before you use the bolt again, so you don't deteriorate or cross thread or fuck it up as you actually go to install it on the truck. So if you're doing it the redneck way, that is a valuable thing to understand that you got to keep in mind to make sure those threads are clean. And one of the easy ways to do it is to put a nut all the way on past where you're trimming and then back it off and then clean that up by, putting that onto the an abrasives deal and spinning that bolt head, whether that's like a multi-tool or a Burr King or something along those lines. What's that new company? Ameribraid. There you go. In fact, we got to order one of those. I do like that stuff. But, so that's the shanking aspect. Now let's get into what would be more of the racing aspect as far as shanking. So if you're going to order bolts from Craig to do this, again, go through the important stuff. So it'd be like chassis pivots. This looks like it might be a sway bar end, but these are going to be the primary sections. So obviously if you're on a little bit more of a budget, or you're trying to use your specific budget as best as possible, you're going to be doing this with the primary chassis pivots. So upright, lower arms in the chassis, upper arms in the chassis, link mounts, housing link mounts, sway bars, things like that, where you would be better to spend the money on these bolts as opposed to like every fucking thing in the truck is going to get RPI bolts. Fundamentally speaking, I do understand that that's just not viable for the vast majority of guys. But if you're going to go in that direction, let's review what you need to do. First and foremost, you're going to start with the grip no washers length. That's obviously going to be the smallest lengths. That's like if you just ignored that there's nothing there, so to speak, no bolts there. So that would be this washer right here to the other side of the table, and that's going to be our washers no grip length. Now, in the past, we've had clients basically just build a spreadsheet that showcases this, and then, just send that over to Craig or ask Craig what he wants from you. Like, build out a spreadsheet that says, hey, I need these bolts done. I'm fucking this up. I need these bolts done in this fashion, lower arm, et cetera, et cetera. And so you can get this number right here, which is grip no washers, and he can easily do the math to get you grip with bolt washer, grip with both washers. So, and those are different numbers. The grip with bolt washers is somewhat irrelevant, although it is utilized in the calculation, because you can multi-stack washers on this end, so to speak, if need be. So the key here too is to understand that when you start going into this side of the table, not only are the washers important, but they are also specific. So the head of the bolt, underneath that head of the bolt, there's going to be a chamfer. You can't get around that. That's how like RPI bolts, race bolts are. There's a special washer that matches that chamfer that then goes against the material. That's the bolt head side. So to be crystal clear, that washer is different than the nut side. So again, you're now adding more complexity than what I was referring to before with like stuff off McMaster. So it's very important you don't fuck that up. Then you have the nut side washer. And now, like I'm saying, if I build my spreadsheet out, let's say this grip no washers is 2 inches. What you do is say, hey, Craig, I need, 10 of these bolts for my sway bar that have this grip no washers of 2 inches. It's a 1/2 inch diameter bolt. Give me this stuff. He'll go in, he'll do the math. He'll make sure that the bolt head washer depth is accounted for. He'll make sure that the nut head washer depth is accounted for, and he'll get you the shank that you need appropriately, because they come in slightly variations. And it was like 100 thousandths different. There was something in there, 1/8 inch different or 100 thousandths different. Let's see if he says it. I'm trying to remember off the top of my head for RPI. But the point being is, he can easily get you a setup for that specific grip no washers that matches appropriately for your shock mount. And so what you'll end up with is a setup, and you might end up with multiple washers on one side, and don't stress that, because what's important is you do not have threads engaging the material that is holding your shock. And with that said, this is a lot more expensive. And so going down this road, you need to have that sticker shock ahead of time. But let's be crystal clear. The guys that are going down this road and taking this a little bit more seriously, for obvious reasons, see significantly less issues when it comes to shock bending, shock failure, things like that. So to do it properly, get those numbers together, understand the washer situation so that your prep guy, you prepping it, etc., don't start fucking interchanging those washers, because they're not the same, and you can't really use one on the other side. You got to make sure the bolt head washer is on the bolt head, and you got to make sure the nut head washer is on the nut head. And Craig will explain this to you, and he'll get you the packs appropriately. So if you're confused or whatever, like, don't even stress that. We've had a bunch of guys order stuff from Craig, because getting stuff for like one truck or one setup is a lot easier just to order it from him than trying to go directly to RPI. Like, you legitimately need to be at like fucking several trucks worth of packs to even remotely come close to having like the buy-in appropriately to get the RPI discount. So that's why when anyone asks me, I just say, just go straight to Craig, get your spreadsheets together with what you want, make sure you understand the numbers that he needs from you, and then he can get you all situated and squared away with. And with that said, there are people that there's obviously other people that sell the RPI bolts. I just know that Craig obviously understands this maybe a little bit more intimately than most, so he can help you with some of the questions you may have if you have a complex or weird mount, and how to get some of those measurements in case you are confused. So he's also a designer, so obviously his understanding of this on the fundamental level is more than just I fucking sell bolt guy. That makes sense. So again, if you're serious about this, that is a route you could totally take and deploy to significantly mitigate issues with the shock bolt. So that's what I'm referring to when I am talking about the shanking of this. And just to review, threads, never a good idea to have on either of those tabs. You want the threads outside of the mount entirely. So let's go. So this is let's start with this arm. So this, like I was saying, is a shock pocket style arm. So let's we're going to hide some of these plates real quick. Hide this guy. Hide this guy. Hide this guy. Hide this guy. I know it's a little dark, but you should be able to see what I'm getting at here. So the pivot in this arm is designed to where the rest of the arm is built outboard from the shock pivot. In other words, we're building the shock pivot first. And it's done so, like this plate right here is a cover plate, so to speak. So it goes in secondary. This is obviously a cover plate. This is obviously a little cover plate. And so this is what the mount would look like building it in the assembly. So let me just hide some of these other guys. This other overlay. This is one of my T4 trophy truck arms. A little bit more complex. Be crystal clear, not everyone likes this type of stuff because of the tubes do add a little bit more time consumption in fabrication, but I really like it. Just this is a personal preference of mine. So there's definitely an argument that could be made that it's stupid, and I'm okay with that because I understand why someone would not like this arm. But the point being is this shock pocket is built, and then the arm is built around it. So in this scenario, this would be incorrect, just so that we're clear. I am well aware that in this CAD file, there are threads in the inappropriate area of the shock pocket. This is just a standard 12-point off McMaster. So for CAD purposes, it's fine. For real life purposes, don't fucking do this. So before someone just completely admonishes me like, oh, Jason just went on the rant for the fucking, shank stuff, and then just fucking shows us a model where it's shanked inappropriately. I just dawned on me how dumb that sounds, but you can't all be fucking YouTube experts apparently. So what I want to point out here is I am creating a pocket, and then I'm creating the internal ribs to match said pocket. So like this rib here comes into place, and it matches up with my shock rib right here. We have another one that I just hid that comes over here and matches up with him, and then the other plate matches up with him and moves outboard. So what I'm doing is I'm creating a pocket that welds up, and then the plates are appropriately lined with the shock pocket, and they go outboard from there. So another example of that is, we'll pull up our packet. Where am I pulling this from? V6, front suspension, lower arm. So this is kind of from last time, but what my point is it's a broken. So there you go. You can kind of see in this this scenario right here, these cover plates line up with these shock tabs. So this interior plate here lines up with this shock tab, creating sort of like a length ribbing that appropriate aligns with the areas of the arm they're going to see the worst sort of abuse or maximum amount of force. You can see this again here. This internal rib lines up with him. This plate right here lines up with that guy. And here is another perfect example of that. This is the shock tab right here, shock tab right here. It's not in this arm yet, but as you can see, these are lining up appropriately and brought into where that pocket, so to speak, is designed, and then it's brought forward to the bearing cup. Even though that's not a rib that is the same plate all through the arm, they're three pieces, so to speak, because they're going into a shock pocket. They still create this sort of flow, and ID is the same way. So this is a shock pocket. Then you have this plate that comes in from that bearing cup, and it meets up with this internal shock rib. And this guy right here, this one goes inboard to the chassis to the other bushing. Yeah, there we go. So you can see that. So you're designing that part of the arm around the shock pocket, and that's what's dictating some of these parameters and constraints. And then for obvious reasons, this part of the shock pocket, he comes forward to the bearing cup. So you're tying this together with multiple pieces as opposed to doing a full-length rib. Now, on like a full-length rib is a little different. Like on this arm right here, you can see I've got some ribbing in here that creates some full-length type stuff. It's a little bit more complex of an arm. This is an all-wheel drive arm, and there's some complexities in this with how the force is applied, so to speak, that's a little different than some of these more traditional two-wheel drive arms. But let's come on. There we go. Okay, so here, this is a slightly different deal. This rib right here is the shock tab, and it's all one piece. It comes all the way through. Same with this rib right here, and this rib comes through and then back. So again, it's still creating this similar situation. It's just two ways of doing it. Either you're building your shock pocket first and then building outboard from that, which is what this arm is right here. So the shock pocket's built first, and then I'm building outboard from that. Or you're doing it where it's just one big rib and the shock mount is part of the rib, and then you continue forward. So it's one plate from cup to cup, so to speak. Now, both of those can be easily fabricated to be plenty strong enough, just so we're clear. So it's not like one is better than the other. It's different strokes for different folks and different fabrication styles. Clearly, the ID arm and like that Herps arm that Craig drew are plenty strong enough for these applications. Like, it's just, like I'm saying, maybe fabricator preference, maybe builder preference, designer preference are what's dictating those sort of variables, as opposed to like whether or not one arm is stronger than the other, or if that rib is not one continuous piece and it's three pieces instead in a shock pocket style, well then it's shit, right? No, that's not how it works. These are just variables, and I've drawn arms, and obviously I've drawn arms in both situations, and so are these other guys too. Although I don't know if David ID has. I'm sure Craig has. I would venture to say Craig has drawn a various different situations with arms. So it could be something as simple as like the builder and the fabricator dictating, I like this style over X, Y, or Z. And then that is what's delineating the preference moving forward for the specifics in the design and completion of the arm once they figure out the shock geometry. So that would be, you know, shock pocket style arms. And if you notice that trend of you're lining up those bits relative to your shock pockets, so you're not just indiscriminately placing the other aspects like all willy-nilly, you know, you are appropriately, what am I doing here? Oh, I got to bring it back. Okay. You are appropriately building the arm so that all of this is like pre-planned. So like these shocks are obviously in place, and then you're planning out this ribbing to match and line up with our shock pivots and carry that forward. So from cup to cup, so to speak, is a nice line and load path relative to that forward shock mount. And you can see that in multiple arms, like same with these Herps arms. And those are the newer generation. Let's see if I find the old generation ones that dumped in. They're somewhere in this pack. And it's that same aspect carried forward, that you're still creating that load path from cup to cup. See, here we go. You're bringing this guy in a fashion that meets up with this rib right here, which is the forward-facing rib of the rear shock mount. And then that rib continues forward and then carries to this side of the cup. This guy comes over here, comes inward to the rear side of the front shock mount, and then he carries forward to the bearing cup. Front side of shock mount carries forward to the bearing cup. So again, even though it's a shock pocket style, we're still creating that load path from cup to cup, even though that plate itself is 3 pieces in essence, if you were to, you know, separate it out, as opposed to it being one rib like in this arm right here, where this is one rib that I have laser cut all throughout. So two different ways to different strokes for different folks in that fashion. Now let's move to shock mounts on top of the arm. And this is a very important thing as well, because just like the other aspects I'm referring to, you can't just like willy-nilly place ribs inside the arm and then just put the shock pockets on top of it, because you could run the risk of puncturing through the arm, fucking stuff up, things like that. And it could go sideways real quick. So let's start with something super simple. This is one of our stage 1 arms. And again, you know, a style of mine, a characteristic of mine that I do deploy is creating the best load path possible for the shock transferring, you know, load into the arm, so to speak, or vice versa, because the arm is obviously compressing into the shock, and stuff like that. Man, this coffee's good. So, it's just so good to finally start drinking coffee again. Those of you who have known me, I've been battling some fucked up health issues for the last few years, and I was not able to drink coffee at all for like a 2-year period. So getting back to that is a wonderful thing. So anyways, we are basically in this scenario, I'm making sure that at no point in time do we have a shock pivot that has open space underneath it. So as we're looking at this arm right here, we are, oh look, properly shanked. How about them? See, now this is properly CAD shanked, mind you. Fuck yeah. So you can see the thread on the opposite side. So these are 1/4-inch tabs. The top of this arm is 3/16 material. The internal ribs are 1/8-inch material. And if you notice this sort of, the way this is laid out is I'm creating a situation where the shock tabs on a minimum of one side transfer load directly down into the internal ribs. So for this, let's flip him over. There we go. So you can see this guy right here, he's obviously transferring into this side, please. We're going to hide this top real quick. So this guy right here, this forward one, he's right above this internal rib on that front-facing side. And the rear-facing side is right above that other rib, that side plate. This one on the back side of the arm obviously is really grabbing this guy. But I extend this tab all the way rearward to cover that tab. So it's like spanning this whole bridge, so to speak. And then this internal one, again, he is spanning to this side and spanning to this side, and this guy is spanning those. Now, he is open, so to speak, so there is no rib under this front corner. But again, I'm not really concerned about that because this side of the rib is underneath, massively spanning that. So you can get away with like one corner sort of hanging out because it's underneath the ribs in the other fashions, and typically you won't see him dive in. That would be very odd, but because the majority of it is designed in a fashion that is carried through the ribs that are underneath. So this also brings back to the conversation that like those internal ribs are placed appropriately relative to like what I wanted to do with the shock package ahead of time. You know what I mean? So I understand where the shocks roughly are going to go and things like that, so I can place those internal ribs to span the vast majority of that scenario. Again, here is another arm. This is a stage 2 arm where I'm doing that same exact thing and mentality to eliminate issues with it wanting to poke through the arm or get fucked up. So we're going to hide this top plate. So now you can see this arm is a little bit more stout. I am literally lining up these internal ribs directly underneath these shock tabs. So even though the shock tabs index on top of the arm, and I'll get to the reason for that in a second, I am appropriately matching the internal ribs to the top of those shock tabs so that load transfer is ideal. And then notice I'm spreading this guy. Like he comes all the way forward and carries up to him. He comes forward and carries over multiple ribs. Same with this guy, and same with this guy. So you can start to understand that it's not just like you're just fucking willy-nilly throwing these ribs in there and letting it ride. They're all placed appropriately so that what happens is that load path coming down from the shocks or up from the arm, so to speak, because again, remember it's compression, it's shoving everything up like a motherfucker, is done so to alleviate a potential issue of punch through or fuckery to some degree. And if you don't do this and you just place these guys willy-nilly without understanding where the internal ribs are, without understanding where the shocks are relative to the internal ribs, you're going to start punching these fuckers through that top plate. I don't give a shit. If you make that top plate 1/4 inch 4130, it's going to bend. It's going to start punching through. It's insane the amount of force that you're going to start bringing into the arm with these guys. I mean, these are heavier trucks, things like, I mean, even the lighter trucks. This is just a good rule of thumb. This is a great way of doing it. And you always want to focus on getting that shock tab to span sort of the bridge or span the arm and the internal ribs appropriately to get all that load down and diminish any sort of spots that would be sitting in open air, so to speak. So cool. So, yeah, so we're viewing that. Shocks mounted on top of the arm, matching internal ribs. Cool. So now let's talk about a crossplate internal ribbing. One of my pet peeves is what's considered crossplate internal ribbing, and I typically try to avoid that as much as I can. And so what that means is, let me find a good example of a crossplate internal ribbing arm. Hold on. And I'll explain to you why I don't like that in a second, but let me just find an example so that you understand what crossplate internal ribbing is. So these arms do have crossplate internal ribbing, but again, these are shock pocketed arms, so they're being built in a fixture and built outboard, so you can't really get around that because of how they're built. And that's not necessarily a good or a bad thing. We're just getting into splitting hairs with differentiation of style and preferences. So this does have some crossplate internal ribbing. So this right here is crossplate internal ribbing. In other words, these two ribs intersect and interlock in a fashion. Now, when you're fabricating this arm, you have the bottom plate typically will go on. You're going to interlock your ribs, and then what you have to do before the top plate goes on is you need to get some weld that appropriately contacts these on both sides. So you're going to have to put heat into that arm before the top plate comes on. That is what I'm referring to with crossplate internal ribs. And so I try to either avoid that or minimize that with these style of arms. In other words, the non-shock pocket style arms, you want to avoid that if you can, or minimize that as much as you can. Another trick with these ones, oh, fuck, I did not do the pictures for that. Damn it. And I don't have that ESOM file on this. But basically, this section of the arm is built on on the table separately, and then it comes into play. And then this section is built independently, and then it comes into play. And then the third section goes in. So this is a totally different way of doing it, and showcase that a different time, because that is maybe I'll review that specific style next episode real quick, because I do need to have like an appropriate ESOM to explain that efficiently. But let's go into another example of a cross pocket internal. There was one in here, and I think it was the Tisco arm, if I remember correctly. There we go. So these are all cross pocket internals. So in other words, before you put this top plate on, all these cross pockets need to have vertical welds in there. Otherwise, it's basically like doing fucking nothing. So it's like worse than it's like pointless. So you got to make sure you have legitimate connection between these plates in these little sections. So the reason I don't like that, and the reason I like to avoid that, is you're introducing a lot of heat into the equation without the top plate on, and all that does is typically add to the fuckery with it wanting to move around more. The less welding you can do before this step, the better. So if you have the top plate go on and then you start doing all the welding, that's a much better scenario. And so I designed to where the arms and components are done in a fashion that we avoid these cross plate sort of interactions, or we minimize it as much as we can. So like here's an example. The only real cross plate interaction is like this guy in here, and then the top plate goes on, and then he can get welded up. And so I'm minimizing warpage, so to speak, in that fashion. Same with like this arm for Ross King. There's none in that. So it's literally just a clamshell, and then you can burn up this arm and then put the pivots in. So here's another example of spanning the shock mounts relative to the internal ribs. Again, just another way of doing that. Here's another one. It's optical illusion, but there are no crosses. So these guys actually have holes on the outside that allow it to weld from the outside. So you can appropriately put the top plate on and then weld up all the critical stuff from the exterior, because I have a lot of windows built into the tab slot side of this arm, so to speak. Trying to find another example of that. I had one. There we go. So in other words, like this is like I was explaining last time, is you're putting the top plate in, very minimal crossing, so to speak, so that what you can do is turn and burn the arm appropriately with all that stuff in there. So let's reset all the plates. So yeah, so like on this guy, we can hide fixture tooling, or we can probably just go back to this guy. We'll revert this guy because it's less time consumption. So like on this arm, these are our stage 1 arms. You're basically just turning and burning with everything in there appropriately. I'm going to hide these guys, because obviously those go in after we get the arm completed. And so this is why I liked having reducing the cross plate stuff. This is a very simple arm for obvious reasons, but the point being here is this arm just snaps together, and then you weld up the majority of it, and you start with like the tab slot welds first, and then you go to the circumference, and you do this without the pivots in it, and that drastically reduces the arm wanting to move at all. Because what you're doing is you're not really introducing any heat until the arm becomes more of a box structure, and that will drastically reduce twist and other bullshit that you'll see the arm wanting to manipulate as you fab. So if you're real particular about that, again, this is just one way of doing it to help minimize and mitigate some of those issues. And like on this arm, and a lot of the arms, like I'm saying, is you can window out these internals. So, like in this section right here, this plate that comes through, he comes through in a fashion to where I don't have to go inside and weld this guy. I just snap the top plate on, and this plate will be welded from the exterior, and it's enough of a connection to where I feel comfortable that we're good to go. So he gets welded over here, gets welded over there. So in other words, we're not introducing too much heat until it becomes a box structure. And like I said, When you can avoid that, it's always better because you're reducing the chances of the arm wanting to start to bow or get cattywampus on you, and they definitely will. I mean, these are sheet metal components that like to move around. So anytime you can decrease that, the better. So that's cross-plate internal ribbing. And like I said, I'm not the biggest fan of that. I typically try to avoid that as best I can. It doesn't mean that if it has it, it's fucking wrong too. It just means you got to be far more mindful of stuff wanting to move around on you. Here's another example. This is an arm for Izzy where these are cup-to-cup plates. And I avoid a lot of cross-plate internal ribs to avoid some of that deflection during the welding process as much as we can. You know, you can never eliminate it, and that is also that sort of exterior welding process style I'm referring to, where you get as much, get it clamped together and weld the exterior mostly. So you're not like having the top sheet removed, welding a ton of the interior bullshit. I try to eliminate all of that entirely to where everything critical can be welded from the outside. That significantly reduces movement. Significantly. Whereas sometimes you'll see guys where it's all welded on the interior. And I'm not referring to the shock pocket style of arm, because those are done in that fashion, but it's done in a way that they're not near as bad as you would think, because they tend to flow better. They tend to have much better tooling and fixturing involved to appropriately account for that. The other trick too is like having the appropriate spreader in this tooling as well. So like on these arms, there's actually a machine piece that goes in here that threads in. It looks a lot like these ones. Again, yeah. So so they have a machine spreader in here. So stuff like this obviously is more expensive to do, and can help big time with avoiding any issues and what I'm referring to as well. But not everyone is going to invest in some of these, more badass sort of characteristics when it comes to getting that dialed in. And so you have to keep that in mind. So like here you go. Here's the machine spreader that holds this guy appropriately in the fixture. And I'm not the first one to do that. Like I'm saying, like this arm done by Craig has it. Again, this is just another old school way of doing it. Unfortunately, this adds more cost. So there's your trade-off. Once you start getting more wazoo, the cost just starts to go up. And some guys are okay with that. Some guys obviously are not okay with that. So cool. I also review exterior processes on that. Let's go to, and we'll dive into more of this, but so like here's another, and we'll talk some real quick. We'll just glance on some sway bar mounts. I have a sway bar section I will review, but let's, sway bar mounts and lower arms. So here's, I like to mount some of these sway bars underneath the drivetrain in the chassis in the front of these trucks, especially these. Well, I'm sorry. Let me rephrase that. This is a mid-engine truck. There is no drivetrain up there. It's literally just fucking space. So it's underneath the drive line in the front of a mid-engine truck. So this sway bar is facing rearward in the chassis, and the pocket for it is chilling right there. In fact, let's see. Yeah, I've got some examples in this. Bear with me for a second so I'm not confusing everyone. Maybe I don't. And I don't. God damn it. Anyways, we are going to review some of the sway bar stuff down the road in more detail, but there are ways you can build pockets for the sway bars and mounts, and I'll go through that in more detail. I did have some people ask some questions on sway bar mounting. So I'm just trying to think. I don't think I have any specifics on the sway bar mounting in this section, but that's okay. We'll get to that later on. Plate work tangent to bearing cups and things like that. So on the other aspects of this, when you're doing these sort of wraps, there we go. So when you're doing the wraps in these arms, you want the wrap to sit nice and flush with the OD of the cup and your plate work structure. So often you'll see guys, they'll have this plate, the bottom surface of this plate tangent to the outside diameter of the bearing cup or the bushing cup. And that's not necessarily ideal. It's not as clean, and it creates sort of this weird lip that you kind of have to dive around to appropriately wrap said cup. So we're going to hide these fixture plates real quick so you can see what I'm referring to. But the goal here is you want to factor in your plate thickness relative to the wrap that you're going to be placing onto the arm. So here's the wrap. This one in the rear here does not have the wrap on it yet. So this top surface of this plate is tangent to the outside diameter of my bearing cup. And so that creates this really seamless flow with the wrap coming around and complementing it. So it gives it a really nice appearance, and obviously it's plenty strong enough. So when you're going to be wrapping these cups or designing in this fashion, it's definitely considered more professional and cleaner to do it to where you match the exterior or top plate surface to the outside diameter of your bearing cup or bushing. And you can do the math. It's pretty easy to do that, but that gives you this nice clean wrap in the arm that, for obvious reasons, creates a much more professional look. So again, just something to note, that we plate work tangent to bearing cups for overlay wraps, or in general, even if I'm not doing a wrap, I still like to have that plate work tangent to that arm so that it just creates a nice flow on the top. See what I'm getting at there? Nice transition right there. Nice little weld gap, little weld V, so to speak. So, and I do the same for the other side of the equation, or the upright side. Pardon my horribleness with this specific mouse. I should just get another mouse, but we're almost done with this. But yeah, so same thing. Here's our bearing cup, and you can see that I am matching that exterior surface tangent to 1.5 inch bearing cup, and creating a situation where it's a nice flow all the way around in the arm and back to our main structure. It's just one of those things that's like a nice touch. So when you're designing, etc., keep that in mind. Keeps the flow all bitchin'. Definitely will make your fabricators happy as well. And the final product will be more professional. So now let's move on to upper arm fuckery. So we can get rid of this. We can exit out of this. We can go back to upper arms. So let's open up some of the upper arms. V6 start, upper arm. And so what I'm using here is the eDrawings viewer. It's free. And you can download it. And we like to use this a lot for our clients. We design in SolidWorks. And so what I can do is send clients an EASM. And they can then open up these arms and view all the fuckery before I send anything to laser, etc. They can also use this during the fabrication process so that they understand what is going on, and they understand where I wanted plates put, or weld process order and things like that. Again, it's totally free. You can download it directly from the SolidWorks site, and it works out pretty bitchin', relatively speaking. So we're now going to transition to discussing upper arms and the upper arm fuckery. I have another thing of upper arms too. And we're going to take a quick pause. I've got something going on. Fucking toddler is screaming his head off. So let me go check on the wife real quick. I will be right back. Okay, and we're back. Turns out toddlers are fucking insane, and nobody is dead, so they're doing just fine. They're just dipshits. And Natalie, my wife, gets to deal with that. So we're now moving on to upper arm fuckery. So let's start here with the spread of the upper arms. Again, just like lower arms, there's obviously variances. in these between builders and variances in styles and things like that. So the spread of the upper arm, there's a few things you got to watch depending on how your setup is designed. Like here's a Jimco. For example, these pivots here typically need to be far enough forward in the chassis to mitigate any clearance issues on both the shocks and the steering at full extension and lock. So you need to make sure that you're not going to hit that stuff. So first and foremost, make sure that the pivot on the rear side of the upper arm is going to clear the steering rack. And then you obviously need to make sure you clear your shock package. Now the spread of the upper arm, you definitely want it to not be like 8 inches. You want it to be more than that for sure. But you also don't necessarily want to go too far forward and indiscriminately push him too far forward in the chassis, this front mount, because what will happen is at a certain point, your tire will hit or your turning radius will be affected, or you're just going to start really fucking up with your approach angle, ground clearance, things like that. A lot of stuff we design infringe in like 14-inch spread, stuff like that, maybe a hair more. I've done some that are closer to like 18-inch spread. I've done some that are a little bit on the lower side. So it kind of varies, but you're definitely not going to be at like an 8-inch spread. That's for sure. And you definitely don't want to be at like a fucking 25-inch spread. It's just going to be too much. And obviously all of these are J-arms in essence. So that's what we're going to be focused on when it comes to specifics with these characteristics and spreads and things like that. So that's just some real insight in the starting point. So with that, let's see. Upper arm, chassis pivot fixed first, adjustable. Okay, cool. So the pivots of the upper arm, whether or not we're going to make those fixed or adjustable. Pretty much everything that you're going to see in the tube chassis side of the industry is going to have adjustment in the upper arm and no adjustment in the lower arm. Typically speaking, when we're designing this stuff, components, things like that, we're able to have a final product that is accurate enough to where you may need 1 or 2 threads, maybe 3 threads of adjustment in real life relative to the computer to get our settings where we want. And that would be camber and caster at ride height relative to where, like say, for example, I initially designed it in CAD. Now, when it comes to the long travel based stuff and things that utilize stock mounts in the chassis, so let's just pull up another long travel manufacturer. Oh, yeah, let's go. LSK. They make a bunch of kits. So let's see if they've got any good pictures of a kit on a truck that I can use as an example of what I'm referring to. So here's one. I can't tell what they... So this one does replace the stock upper arm mounts. Not a good example for what I'm trying to get at. So on long travel based stuff, you have a few ways of differentiating these kits in relationship to the upper arm adjustment on the chassis or non-adjustment on the chassis. So when you build an upper arm that does not have adjustment, so like here, for example, here's an upper arm that does not have adjustment built into it. In other words, I can't change the length of these bushing packs at all. But what's happening here is this is going into a Toyota Tundra. There's adjustment built into the chassis side, the stock assembly, so to speak, that can allow us to move appropriately to get our camber and caster alignment where we want it to be. So again, we have adjustment in one side of the table to get us where we need to be, even though these arms are non-adjustable. So if you have like a Silverado, etc., and some of what's common, like in this application, well, this is a Tundra, but it's no different. This is a race kit. Typically speaking, a lot of long travel stuff, we will remove the stock pivots, like the cam locks and things like that, make the upper arm with rod ends in it so it has adjustability, and then now the chassis side loses its ability to be adjustable. So those are two sides of the table when it comes to like long travel or stock-esque truck stuff is if you have an arm that has no adjustment in it, typically speaking, you are maintaining adjustment on the chassis side so that you can get your parameters where you want for camber and caster. If you're doing like a race kit like this, and several manufacturers do this, where you cut all the upper arm mounts off, you weld on a new assembly like the shock mount, and so you lose the chassis side of adjustment, but you gain that because we're putting rod ends into the upper arm. So that's the majority of the long travel-based stuff, or the proper way to do it. If you hard mount with no adjustment on a truck like this, so to speak, that would be considered kind of not great, kind of a bad idea. So this is obviously a non-adjustable mount on the chassis now, but they have adjustment in the rod ends for that upper arm. And that is the proper way to do it. This would be the inverse of that. There's no adjustment in the upper arm, but they maintain the adjustability in the chassis side of the table. So just two different ways of looking at it, different strokes for different folks to some degree. But that is, in other words, you don't want to have the chassis side become non-adjustable and then do the upper arm non-adjustable. Now, I am well aware that all of the fucking UTVs and shit like that are done in that fashion, and I completely understand and get that. I just am not a fan because you're deteriorating the ability to get the car dialed in, so to speak. So on the UTV side of the table, it basically is a complete headache, because what happens is you have no way of correcting camber or caster alignment because it's fixed pivots in the arm and fixed pivots on the chassis. They do this for simplicity. They do this for manufacturing purposes. They do this for cost. So on the UTV style of applications, some kits are that I design do not have adjustment in it. We just rock it like stock, so it is what it is. But it's not uncommon for UTV stuff to where we will add adjustability in one side of the table. Now, typically speaking, with adjustability, you want to have adjustability in the arm that is not mounting your shocks. The reason for that, or the reason why that is preferred, and in UTVs this is very important, is because you don't want to start changing the motion ratio of the shock in the chassis. Now, I understand the argument could be, well, it's like a fucking 16th of an inch here or there, but still, you're adjusting the motion ratio that initially is in the arm. I'm just not a big fan of that. If you're a stickler for that type of stuff, you want the adjustment side of the table to be in the arm that is not carrying the shock load. So on UTVs, you typically see the adjustment side of the table, or what I prefer to do is put the adjustment into the lower arms when the upper arms are holding the shocks. Or if you have like a Wildcat XX where the shocks are mounted on the lower arm, the adjustment side of the table is then built into the upper arm, not the lower arm. Or you could put adjustment in both. But the point being is, if you avoid adjustment on the arm that's holding the shock, that is typically a better scenario. And you utilize the non-shock arm to get your camber and caster where you want, relatively speaking. So when it comes to big truck stuff, rear-wheel drive truck stuff, all-wheel drive big truck stuff that you are seeing with trophy trucks and things along those lines, common practice and industry norm is building the adjustment into the upper arm only and not having any adjustment in that lower arm. Now, with that said, let's go into some differentiation in that too. So, in the non-adjustable side, and again, you're not really seeing this in competitive trucks. No matter how fucking badass we do all the fixturing and the tooling, like I'm saying, you're still going to want a thread or two of movement or 3 threads of movement in the upper arm assembly. And that's like with the most baller as fuck fixturing and tooling ever available, you still end up with needing that in the equation, so to speak. And so, if you're not putting adjustment into it, they'll run like Delrin here, like UTVs, you know, like the Wildcat XX. It's Delrin on the upper arm. And again, you run into the same style of problem you would, like I referred to with the lower arm stuff, where the Delrin pivots on the bolt. It's a linear pivot. If those bolts for the upper arm are cattywampus slightly, or the chassis mount is cattywampus, you're inherently putting bind into the movement of the upper arm. If you're using a rod end or a spherical bearing for the movement of the upper arm, and pretty much all of them are rod ends on the big truck stuff, trophy truck on down, you are now pivoting on center point of the rod end. So any bind inherently built into, or accidentally, just be crystal clear, accidentally built into the either upper arm by these pivots not being perfectly parallel, or the chassis pivots being cattywampus because of welding, heat, or warpage, because we're assuming that in the computer the design is fucking titties, like it's perfect. So you're taking that out of the equation because you're pivoting on the center point of the rod end spherical bearing as opposed to like a Delrin bushing. So again, right off the bat, that's another negative for running a Delrin bushing or a non-adjustable mount up top, and another positive for running rod ends. And that's also why that is, in essence, the most common thing you see. Now, moving past that, let's go into the differentiation between a pinch bolt and a non-pinch bolt. So let's look at here you go. Here's a non-pinch bolt arm. So these are standard square bungs that utilize a jam nut for the rod end. Now, if you're a stickler for rod end movement in the arms, you could make the argument that this is not a good idea and it's bad. But unlike a rear link, like an upper link and a forelink, or a rear link arm, the jam nuts typically do not move in these applications because the rod ends are moving in unison, so to speak, on one line, one plane. They're pivoting around that one axis, both of them. So it's not like a link arm in the rear end assembly where there's a lot of twist and movement that could, in theory, take that jam nut and tweak him out of being locked in place or spin him off of being tight. So in these upper arm aspects, it's not necessarily a bad thing to run a jam nut because typically speaking, they're only pivoting up and down on the bearing. There's not a twist in the rod end, so to speak, so that it's wanting to inherently or naturally through the movement of the suspension, wanting to de-thread that assembly. So right there is kind of like a natural ability for this to not want to pull the jam nut out of being tight. So again, it's common practice that this is totally acceptable and totally fine. And the inverse side of the table would be running a pinch bolt. And so pinch bolts obviously have other positive aspects to it. And the main one with the pinch bolt is that I can now have more thread engagement of the rod end into the assembly, so to speak, because you have to remember the jam nut is hanging out past the material or the a component, whether it's a machined arm, whatever you want to call it, or a fabricated upper arm. That jam nut is hanging out past. So the argument could be made that it's much better to have a pinch bolt style because you have more thread engagement. Now, even with that said, and when I do the jam nut style stuff, you can see I'm running it down to where there's only a few threads showing. Like I was saying, with the practices these days, you're able to get stuff fabrication quality-wise to be accurate enough to where you only need to mitigate a few threads of movement. If you're past that, you may have other issues at play or something else that you need to look into with your process, because you don't want more than like 3-4 threads showing at any point in time, whether it's a jam nut or a pinch bolt. You can get away with a little bit more. I know guys are in 6, 7, 8 threads showing on a pinch bolt. Again, that kind of irks me. I'm not a big fan of that. I'd prefer to have a lot less, like 2, 3, 4 threads showing on the high side. The less threads showing, the better, more engagement into the actual component, so to speak. Now, with that said, the pinch bolt then is now holding more threads too. So when you have a jam nut holding the rod end and you tighten the jam nut down, you're basically only having the rod end hold, 2 or 3 threads of depth as far as like it legitimately holding to the jam nut and holding in place in the bung. The last series of threads aren't really held too tight, so to speak. The jam nut's only kind of holding those first few threads of engagement, legitimately speaking. With a pinch bolt, the argument can be made that you're holding more like 5, 6, 7, 8 threads of engagement because now you're pinching the assembly and you're capturing more threads down the neck of or down the shank of the rod end more. So the valley and grooves, so to speak, between the threads have a better engagement on a pinch bolt style rod end. So they typically hold better. and you'll see less of an issue, typically speaking, of the vibration, so to speak, or the wiggling of the rod end in the arm that could, in theory, cause a situation where the rod end would then want to snap. Again, very odd if that happens, but that is something to think about. So on some of the more nicer stuff, like these fabricated arms here, typically you will see pinch bolts for the majority of trophy truck style builders, although, like I'm saying, running a jam nut is not necessarily bad as well. They both work, typically speaking, more than fine when done properly and have enough engagement. As you can see here, a few threads showing in this arm for an all-wheel drive TT. And look at that spread too. So like on the all-wheel drive stuff, I open up the spread even more than the two-wheel drive stuff, and that's because, for obvious reasons, you have a fuckload more force in the rotation aspect of the front assembly, especially when it comes to grabbing, biting, and pulling that vehicle forward. And you'd be surprised how much force comes into play to where on the upper arm, I want to get that spread, and same with the lower arm, get that spread a lot more than the rear-wheel drive trucks. That's just my opinion and thought process, because on the rear-wheel drive trucks, I obviously run a lot lower spread, but on the all-wheel drive stuff, I open that spread up a fuckload to help mitigate any issues with the increase and uniqueness of how the all-wheel drives apply force in the assembly, so to speak, under speed, under throttle, and, you know, just fucking getting after it. So, with that, and then single versus double pinch bolt style. So let's look up that. I typically almost always run single pinch bolts on the upper arms. Again, and this is because a double pinch bolt assembly, and let me show you what that looks like real quick, is primarily catering to something like a rear link arm, in the fact that on a rear link arm, etc., in the chassis, the rod end is legitimately pivoting around the bearing center point, and it can move in multiple directions. Where on the upper arm, even though you have two rod ends, they're still only moving in plane, so that they're not wanting to twist the rod end out or de-thread the rod end as much as you would see in like a lower, like the rear link arm stuff. So again, Cartech is another good source for dual pinch bolt bungs, and get ready to, you know, get some sticker shock. You start stepping into more of the rate. So here's the other side of the argument: is the pinch bolt bungs are, where the fuck are they? Let me try. I probably just went right past them. I'm just getting too old for this shit. There we go. Are more expensive. So for obvious reasons, like let's look at what the cheap stuff is first and foremost. These guys, like I like to use these in a lot of our stage 1 upper arms, stage 2 upper arms, things like that. So there you go. $28 for, that's a 5/8 time, 7/8 time. This is a standard for upper arms. Right here. So this is $28. Now, most of these upper, so let's review that Heim size too. Most of the upper arms, so trophy truck, etc., 7/8 rod ends are very common, and they have a great, a great ratio of strength to weight. Because you have to remember, like, you don't want to just start indiscriminately adding a ton of weight to these assemblies for no reason. Because once you go past the 7/8, you go into a 1-inch rod end, it's literally double the weight of that fucking 7/8 rod end. Now, you also, on the big truck stuff, so full-size trucks, you typically are not seeing rod ends going down to 3/4 of an inch for the upper arm. An industry practice / norm for at least like the last 15 seasons or so, builder-wise, is to run 7/8 bearings or 7/8 rod ends for the upper arm pivot on the chassis side of the table. 1.5 inches for the other side of the table. And I can get into that some more, but for 3/4 inch rod ends on the chassis side, like you could get away with that on a lighter truck, a sand truck, maybe a lightweight 7200, a mid-size pre-runner might be able to get away with that. But common practice these days is 7/8 inch bearings, rod ends for the upper arm. So for obvious reasons, this guy is $28. Now let's dive into the dual pinch bolt and single pinch bolt relationships. So dual pinch bolt style. So 7/8, see, look, now you're at $100 right there. And like I'm saying, this is not necessary for an upper arm, in my opinion. You can do a single pinch bolt simply because on the upper arm, like I said, the arm is rotating with both bearings in one linear fashion. So there's no inherent twist wanting to de-thread that rod end out of the assembly. And here you go, $70. I know it doesn't sound like a lot. The argument can be made, oh, well, it's better so you could run more. Well, again, like I'm saying, you're just adding more weight. You're adding more cost for, in my opinion, like no fucking reason on an upper arm. Now, on a rear link arm, you definitely want a dual pinch bolt bung, and I can review details in that in specifics when I get to the rear suspension stuff. And at this pace, that's probably going to be like a fucking year, given how much I can only do like one of these videos a week. So, yeah. And so just to give you some insight into that, that's this side of the table, so to speak, right here. Again, these are those more standard stage 1 style arms. Now, common practice for the bearings on anything full size, anything race full size these days is going to be 1.5 inch COM24 in, similar like I reviewed with the lower arm stuff last episode. Very rarely are they running what are considered the big trophy truck bearings these days. Rarely. Now, let me show you an example that is running the bigger stuff. And this was a specific request from said client. This arm right here. So we are running 1-inch rod ends on the chassis side and the big trophy truck bearing on this side. Now, to be fair, this is going on both a trophy truck and a matching crew cab luxury pre-runner that is easily like 8,500, maybe 9,000 pound range. I mean, it's getting up there. And then fully loaded, it's probably 10,000 pounds with 4 guys in it and all the gear and stuff you throw in there. So this would be on the high side or the more extreme side as far as weight goes. So this arm specifically, per the request of the clients, was done to be very robust. So we went a little bit gnarlier than normal. We went with the big trophy truck bearings and 1-inch rod ends on the chassis side. Now, granted, like I said, with race truck stuff, or the vast majority of this type of stuff, a 7/8 bearing on the interior is more than fine. Now, on this older Jimco, they are running dual pinch bolts, but like I'm saying, it's borderline irrelevant. I just don't think that's worth it. It just adds cost. So here's, again, 7/8 with the COM24 or a standard 1.5 inch bearing and single pinch bolt setup. Now this is a much lighter weight arm. This actually has an upright that uses 1.25 inch bearing, and these are 3/4 inch rod ends on a very lightweight 4-cylinder turbocharged 7200. Again, here's another arm that just uses 7/8 with the standard 1.5 inch bearing. But yeah, so now let's talk bolt holes. Bolts that are utilized for the chassis side pivot. Now, you can run various different spacers and things like that. So for the bolt hole sizes and the spacers, so let's go back to CarTech just to give you some good examples. Spacers, how I'm doing. So we'll use 7/8 because that's pretty much our standard for a lot of this stuff. On the upper arms, you do not need to have a high misalignment spacer. So these are not necessary and basically make zero difference whatsoever. Now, they are a little bit more costly, etc., but so whatever. You could use those. I just typically steer away from them and just use a spacer like this for the upper arms. Now, this is a 7/8 on 5/8, 7/8 on half, etc. I have also used 7/8 on 9/16. So the smallest bolt hole or bolt size that you would use for an upper arm pivot on the chassis would be 1/2 inch. That's a little bit low for a lot of like race truck type stuff. On the high side, the vast majority are going to be a 5/8 diameter bolt for the pivot side of that 7/8 bearing on the chassis. And some do 1/2 inch. I have done a bunch that are 9/16 as well. 9/16 is totally fine. Again, as you step up, the argument can be made, is it worth it, and are you just adding weight for no reason? So 5/8, again, would be considered pretty normal for 7/8, same with 9/16. The 1/2 inch, on the other hand, with the 7/8, I would say would be on the lower end side. Some guys do run 1/2 inch. Like if you're running an RPI 1/2 inch bolt, it's properly shanked, and the mount is properly done in the chassis to where there's no issues with the bolt being fucked up, and it's a proper assembly, you can get away with 1/2 inch. Now, like I'm saying, granted, the vast majority of guys are not necessarily doing that all rad. So a 5/8 is more common and standard. So we typically tell guys and design most of the stuff for 5/8. Although if you're a little bit more advantageous for the weight aspect and you want to get a little bit more proper, stepping that down to a 9/16 or a 1/2, and you're using like RPI hardware, you can totally get away with that, because that 1/2 inch RPI bolt typically is going to fail after you're going to snap the shaft of a 7/8 rod end, typically speaking. Of course, in off-road, every fucking thing can go wrong and get cattywampus and fucked up instantly. So don't take that as a fundamental norm. Like I'm saying, it is still hit or miss to some degree. So spacers for bearings, we went through that. Yeah, let's review some of plug welding and how you need to appropriately attach said bung. So these are plug welds. Let's see. I think I opened some. I thought I opened those arms. Let's go back. Maybe I accidentally deleted that out. Trying to use our fancy new e-drawings for my podcast. I know I've been sticking to just pictures only and stuff for our time. So let's get this to load. Just bear with me for a second while I see why my wife needs. Okay. Everything is fine. And it's not working. So, managed to fuck that up somehow. Anyways, point being here is you can't just, sort of like weld your bearing or rod and bung receiver into the arm without making sure you appropriately plug weld it. So here is a standard square bung, and here is your little rosette plug weld. Now there's a few ways of doing this, and I'll explain like my preference with it. So like this, we have a ton of attachment on this arm. Right here, this was a builder preference in this situation. By the time these are 2 tubes welded circumference-wise, and then this plate gets in a weld, that ain't going anywhere. If you're welding that properly, this ain't removing. So that I'm fine with. Again, different strokes for different folks, but with the platework style stuff, we always like to have it pretty into the arm. Man, that is disappointing. That is not opening. Or wait, maybe I already have it open. Let's see here. It is open. So it's me that is special. Fuck, it's like multi-opening. Get that out of here. Get this out of here. There we go. So here is a stage 1 arm. And you can see this is out of the way. I don't know what that is. There's some geometry aspect that's hidden in there. Pull that out of the way. So here's our square bung right here. And what we have is a little rosette on the top and bottom sheet that holds the backside of that bung. So this bung is only so deep into the arm, so to speak, and you want to get the rosette weld towards the backside of that depth so that you have weld on both sides. So obviously the circumference of him is going to be welded all the way up, all the way around, and then we're having these plug welds put into place as well. So here's another perfect example of what I'm referring to. This bung ends right about here, so I am appropriately placing the plug weld towards the backside of the bung. You don't want the plug weld to be like over here and then have the bung just chilling with no weld in this part of the arm. You want this part of the arm to appropriately be plug welding towards the back of that bung. So if you just notice what I just did, that changes. That tube's not supposed to be in there. That was an old rev. This is the old plate work rev. So you can see that the plug weld is set to where it's grabbing the backside of that bung and welded it appropriately. And so that is creating a nice multiple fashion grip, so to speak, in that bung. And I can show you some other examples here's another one. That's an old one of our like Rock Racer-esque arms. A little bit different of a bung there. So here's another example right here. Again, you can see. Okay, so what happened was I lost audio. So there's a solid like 30 fucking minutes that I just lost on the audio side. So we're gonna pick back up on what I was just referring to with some of our bits in relationship to the plug welds. So let me find that arm real quick. Open that back up. It's interesting which arm it was. Yeah, so this guy. Okay. We can't all be professionals at podcasting, but we can certainly fucking try, you know? So like I was saying is we want that bung or that bit in there to have an appropriate weld towards the backside of the bung, so to speak, so that you're getting connection front, rear side, etc. Now, when it comes to the pinch bungs, I'll dive into the bolt deal in a second, but like this guy, another cool thing is I can show, like this is a cover plate that goes in afterwards. Inside here, that tube's not supposed to be there. Wrong rev. You can see that this plate gets welded to the bung before it gets covered up, so we get a nice connection too on this backside. What's also very important to note with these pinch bungs is you do not want to weld this plate here too close to this bolt hole, and you want to leave some space here for this split. If you weld this guy up against this bolt hole or too close to this split, what will happen is you will create a scenario where now the pinch bung doesn't have the appropriate ability to pinch onto the threads of that rod end. And I learned this the hard way like 15 years ago. I totally fucked this up on some light racing pinch bungs for an upper arm on a center mount truck. And it was like it was the first set of upper arms I'd ever fabricated with pinch bungs, and they were from light racing, and I was emailing with Brian Cadella on that, and it became very aware very quickly. He was cordial about it, but basically told me like I'm a fucking moron because I had welded it so far we couldn't figure out why we kept snapping the fucking bolts of the pinch bolt, and it still wasn't tight enough to hold the rod end from slipping. Well, I learned that lesson the hard way. So you need to have some space in there relative to that assembly, so that it allows the flexibility, so to speak, in that it will appropriately grab and hold and pinch. And mind you, he did compliment me on my welding though, so that was a pretty good fucking day after realizing I had to make new arms. But that you have to learn this stuff. I wish someone would fucking make. They didn't have this type of video stuff for YouTube when I was starting out, so like, there was no one telling people like me, like, these sort of things. So, of course, I'm just fucking doing the plate work, like, literally all the way up to the fucking, like, right here to the fucking edge where it barely clears the bolt, and all the way up to here thinking, like, dude, I'm just making this thing strong as fuck, bro. Yeah, you're going to fuck yourself real quick like I did, because now you deteriorate the ability of that pinch bolt to effectively hold the fucking rod in. And it was funny because like it didn't even dawn on me until it was mentioned, like, hey man, like don't do that. you're no wonder why you're snapping the fucking bolts, because we're having to tighten them down so fucking much to try and keep the rod end from spinning, and it's still fucking spinning in there. So as soon as we went back to not welding it too close to the bolt head, it worked. Fucking amazing. So anyways, another cool thing on this that I want to mention is, so this is a little cover plate, obviously. Now, behind this cover plate, we're going to have this internal rib that gets welded into this assembly. What's important to note here is I have created a gap in this to where the tube can be welded to the bung in there, and then the internal rib can be welded in as well. But the point here is, just like in a tab slot situation, even though it's hidden, I am creating a valley in there so that I can weld that tube to the bung and to the internal rib and get a nice connection of weld bead to the sidewall of the rib, to the sidewall of that tube, and to that base material, which in this application is our internal or threaded rod and receiver / bung. So again, Something important to note with that, as well as the weld too close to the pinch bolt issue. Now, when it comes to the other style of arms, so these guys where I'm using a jam nut style, you can weld him all the way up to the edge without much of an issue. You still want to leave, like, you don't want to go all the way over and get him too crazy, so to speak. Like, this is a good gap for MIG welding. It's probably like 300 and change thousandths, 340 thousandths, 50 thousandths. Or we'll just call it 3/8 to make it simple. And then that way I can weld it all up, and then I've got my plug welds set further back to the back side of this bung appropriately. And now in doing so, that is going to hold that guy really, really well, while also not deteriorating the jam nut's ability to hold. So unlike the pinch bolt bungs, you can run that fucker all the way around on a jam nut style bung, whereas on the pinch bolt stuff, like I was saying, is you got to be aware of what's going on so that you don't fuck yourself. You could get into a bad situation really quickly by over constraining it, so to speak, with too much weld over by where the bolt is, and then next thing you know, you're struggling on that side of the table. And so for obvious reasons, that can be pretty shitty, So yeah, that is there you go. So pinch bolt bungs and non-pinch bungs. We went through that. We went through the plug welding to the bungs, spacers and bearings on the interior side of the table. As always, pay attention to those bits. Don't fuck that up like I did. And you'll be a lot smoother with that. So let's focus on the other side of the table, which is going to be our upright side. Now, typically, like I was saying, almost all of these applications are going to be 1.5 bearings for all the big truck type stuff. Like I said before, most of the guys these days are running just hiding some of those plates out of the way, are running 1.5 bearings, which we've discussed that before. UTV applications for the interior side. Again, UTV stuff, we'll have a whole nother episode for that. Snap ring direction, I have covered this. So on these 1.5 bearing pivots, if it's horizontal, snap ring's on the bottom. If it's vertical, snap ring on the upper arm is going to be facing rearward in the chassis. That's to mitigate brake force stuff. So that's going to be this guy here. Rod end applications for the upper arm at the upright. Not a big fan of this. And typically speaking, competitive trucks, you are not going to see this take place much at all. It is common that they're going to be running, so trophy trucks, things like that, we're all running spherical bearings at the upright assembly for the upper arm. Now, on my UTV, which is an XX, I am doing it a little differently. And let me just figure out, put that zip drive in. The fuck? Why is he not showing up? Okay. There we go. So, slight lag. We're going to look at this real quick. So, this right here is the upper arm for my XX. Now, I am running a rod end at the pivot side for the upright. And I am well aware of the guys who have like the Robbie Gordon speed arms that they run a jam nut style at the upright. I do not like that. That is definitely wrong. Robbie does a lot of stuff that's rad. That, however, is not fucking cool, and it's a fail. And the reason for that is, unlike the chassis side, like I was referring to before, where the pivots move in a linear fashion and you can get away with the jam nuts because there's not really that twist mechanism, so to speak, wanting to loosen up the rod end in a natural state, whereas on the upright side of the table, because you're moving up and down through travel and turning, it tends to want to loosen up that rod end much easier, so to speak. So I prefer a legit pinch bolt style setup in that application to eliminate the ability for the jam nut to come loose on the upright side of the table. So typically speaking, if you do run a rod end at the upright, which, to be crystal clear, for the big truck stuff, trophy trucks, class 1, any of these race style vehicles that are larger than, say, like the UTV, I strongly suggest do not run a rod end for the upright. In this application, which is a Wildcat XX UTV upper arm, I'm sure I'll get a phone call from Robbie on making my own arms at some point, but point being here is you can get away with it. These things are small enough, light enough, etc., different applications. So with that said, in this scenario, we are creating our own redneck pinch bung in that I wanted to run a much larger diameter bolt than some of the other pinch bungs, so to speak. So what I'm doing is taking a piece of material, and I believe this is a 3/8 bolt, so it's a little gnarly for this application to really hold that 7/8 rod in like a motherfucker. And it's just cheaper because I'm buying the cheap bungs and then slicing it after the fact by hand and then running a tap through it. So what I'm doing is welding them on like so. So the red line I'm welding in there, welding this tube on, so it's like a piece of chromoly tube. And then welding the backside. And again, this is like, this is going to be okay for this like little UTV arm, but I'm not doing this shit on race truck. Let's be crystal clear. Or for like the race application for the same UTV. Like the race arms I'm doing are spherical bearings at the upright. So this is like a stock replacement arm. And so weld the front to back, let it cool. Then I'm going to take a cutoff wheel, slice it down the center, and then run a tap through it. And that's like the redneck way of making a really gnarly pinch bung for the assembly to kind of get around what I was referring to with you shouldn't be running a jam nut on the upright side of an arm application like this because it does not function the same as a jam nut on the interior side of the application like this. So now with that said, let's dive into, I did snap ring direction, but yeah, spacers and bolts. So for the upright stuff on the big truck applications, we're running 1.5" spherical bearings. And what's very common, and most of the time, that's going to run a 3/4 inch bolt at the upright so that we're necking him down appropriately, so to speak. And in that scenario, same with like these, although when I get to the uprights and what I like to do with some of the spacers at the top of the uprights, etc., there's going to be some variation in that on the horizontal as opposed to vertical. Vertical is pretty standard that like we're going to run spacers that neck this guy down to a 3/4 inch bolt. And the standard spread I like to run on these is 4 3/8 for like the trophy truck-esque stuff or big stuff because it gives us a nice spread on the upright platework as a whole to match what is the most common sort of snout block size on the upright. And again, I'll go into more bits in that. But the point being here and what I want to stress in the upper arm section of this conversation is, commonly speaking, the spacers that are necking this 1.5" bearing down are going to go to a 3/4 inch bolt on a 4 3/8 spread. That is the most common that I am running in these applications, scenarios, etc. So again, standard issue Cartech part numbers in that. If you're running a 1 inch bearing like we do in some of our smaller buggy stuff that runs a vertical bearing as well, or like our sand truck front ends, those are actually going to be, and let me show you an example of that, a 5/8 bolt that I like to run on the upper arm. And I'm pretty sure I got some examples in this pack. Just to give you like kind of a, there we go. So like this is a 1 inch bearing. This is a sand cart upper arm. Obviously it's way more light duty. These are like 095 material. Super simple setup, 3/4 inch rod ends on the interior, 1 inch bearings at the upright pivot, and we neck those down to a 5/8 bolt. But again, it's a sand truck. It's not seeing the same sort of weight abuse and not requiring the same sort of robustness that you would need in a race truck or a class 1 or a full-size pre-runner, things along those lines. So I can get away with running that smaller bearing and spacer stack and things like that. This is an 1.5" bearing. 1 inch internals, we've gone through that. But the point being here is when I get to the upright stuff, I will review in more depth what I like to do with some of the spacers and applications. Also, I'll do some video stuff onto UTVs because obviously
There's a lot more different stuff that we do in the UTV stuff that, like I said, like on my XX arm, I feel like it's acceptable to do that rod and redneck pinch bolt thing where like I'd never fucking do that on a race truck. That is not ever going to happen. And even on the race arms I'm putting together for my XX, it's a spherical bearing, no pinch bolt bullshit. So again, those are just stock replacement arms. I feel like that's an acceptable application, but not for most. So again, different strokes for different folks in those environments. And so that is a good rundown. I want to stop the video here simply because the next chunk is going to be fabrication upper arm style. And for obvious reasons, we're going to dive into well over another hour and change of information on the fabrication style and things like that. So we'll save that for volume 7. And as always, I'm super stoked that you guys pay attention to this stuff at all, or that are watching this. And just remember, tech consulting is my little deal, and DIY Off-Road, the digital asset marketplace for our industry. So guys like myself, you included, if you do draw your own stuff, etc., can sell non-proprietary design files. And if you want to, just go to the website, DIYoffroad.com, click on the sell button in the top right-hand corner. That'll take you to another fucking lovely video of yours truly explaining to you exactly what to do with setting up your account. Here's a PDF that details out how I like to build out all the packets and all the information for the customers. And then you'll end up with like your own page, etc. So like here is Baker Motorsports. So he'll have his own portal where he can go in and load product, adjust product, things along those lines, and list it. And then you can control all your sales and all that fun stuff. And, you know, for obvious reasons, there's just so much different things that can happen in this fashion. So there's 2 bumper frame horns, fabricated bumpers. So here's another guy selling stuff on DIY Off-Road, Brad Howard Welding and Fabrication. And so like here's his little page with a bunch of his products that are all listed here on DIY Off-Road. So if you are interested, remember, just click on the sell button up there. What'll happen is you fill out this PDF, email us in the thing, click on set up my DIY account so you register. Once you're approved, I will change you over to being a vendor, and then you click on vendor dashboard, and what you will see here is all the tidbits to start uploading product and things like that. So if you do want to sell on the platform, it is very simple and easy to get you set up, and you get to control it just like you would in Amazon store or things like that. We basically just stole the same platform that they're using, more or less. So as always, gentlemen, I appreciate it. This has been another episode of JEHC. Next episode, we're going to dive back into upper arms, fabrication style, and then we'll dive into machined upper arms and a lot of the nuances and tidbits that go along with that party. Appreciate your time, gentlemen, and as always, pitter patter.